Usually thousands of them are green, but it's like the grammar boxes are not pronounced. You have to think.
Oh, that's tricky.
So-
That's what I was thinking, is it's different, but it's tricky.
HTUs. These are HTUs. And these are, this guy is T cubed. See that? There's
That's hilarious.
See on the back it says thousands.
Is this really easier than learning it from the abstract book?
Yeah, because
It
you
really-
have to see the patterns.
Yeah, it's all about the process
Okay.
Because I didn't learn it this way at all. This is why
and understanding.
I learned it old school, right?
Yeah.
But if they can't see the patterns, then they can't visualize it.
Because this to me is a lot more confusing. Than
Well, 'cause you
probably
didn't
because
get
I'm
it.
trained on another
Yeah.
But they love to
You get the
manipulate
sequence,
and
yeah,
play.
Yeah, this is building on.
Yeah, you missed the last two copies that led up to it, but.
Well, actually, this is middle, this is what, this would be
Upper
upper
L.
L, so you've missed the last 7 years.
That explains everything.
Oh.
I skipped a lot of school.
And it just plays with their tendencies, you know, they like the personification and all the fancy
And you get to
manipulation of it. It's just fun, it's like playing a game. Okay, so we did thousands. Yeah. So that's got
10 by
10 squared
by
times hundreds, which is what? Just count your zeros, right?
Yeah.
10 has 1 0,
Mhm.
and hundreds have 2, so it's got 4 zeros. 10 squared times hundreds. So those are your 10,000s. So T squared H for those three. And these?
These are 10 by 10 by.
H times H times 10. H squared. H times units.
10 to the 4th by
H squared times units,
10,000.
which is also
10,000. So I have a question. If you're doing this with 3 students and one of them is having a hard time understanding the concept, do you represent, and even though the other two understand the concept, they gotta listen through that again?
That would be me.
you could represent, and they could get help from their friends. They'd rather to get help from their friends. Yeah.
And does the story come first, or where does the story actually?
Story comes after a lot of cubing work.
Yeah,
This is sort of the end of it.
okay.
But then after this, there's cube roots too, which is even more advanced using this material.
But the story is there to help them set up the
Well, and
exercise,
it
right?
engages them,
Oh, it
it's
does, but-
a story.
But I'm just saying, they understand a lot of the fundamentals, and the story helps them lay out what you just laid out, right?
Right.
Because now, I mean, now that you've told the story, I can probably lay it down, right?
Yeah,
Because I know the story,
they
but I
should
would
be
have
able
been
to.
able to do it.
Right.
Yes. So the first of all, there's all these lessons on squaring,
Right,
and then you have this big, which is the key lesson, where you go from squaring, where you go from the bead bars and you start stacking, and you go in cubing, and that's what uses that big wooden cubing material,
Well, they
which I
just-
didn't bring up here.
They do swearing in the primary classrooms with the
Sure they do.
chains,
Yeah.
in the bead cabinet, so they've been doing it for years.
Yeah, they
And
understand.
they're very
the squares.
comfortable.
So in relation to geometric representation of all this math,
But
they're
that-
good at it.
Doesn't is it the binomial or trinomial cube, is that 3-dimensional version of the Pythagorean theorem, or did I make that up?
Pythagorean theorem is done with the geometry, we have the geometry materials for that. Pythagoras plate. Like there's a squares on the sides of the scalene, legs on the
A square
scalene,
plus
you
B
put a square on the hypotenuse. The height like that, the hypotenuse.
That's all the terms are really coming
Yeah.
back to me.
So this one's h squared u, right? I'll finish.
H
Squared u, and then, what's this one? Look at an edge, that's an h, let's look at a corner. H, and a t, so this is h squared t from those. Those are now, I'm getting really big. Those are 100,000.
Oh, that's what the big cube is. The
Big-
big cube. The
And
one
I even
in the
had-
classroom.
Oh wait, I put one in the wrong becomes the cube of what? 100, which is millions. So I even had, kids that did this once and they go, oh, the million cube, and they go get that big.
Big
yeah.
one.
Yeah,
See,
it's
it
the
just
same.
clicked for me. I just got it.
Same. Yeah. So then, you're writing it all out. And this is a lot of writing. Like you choose, like you say, H equals 300, T equals 20, and U equals 5. So then we have 300 plus 20 plus 5 cubed. And there are all the terms. How many terms are there? 3 cubed terms. There's 27 terms. So we have to go figure out every single one. And then I teach them how to do it. Times, break it down. And then you go through each time. 300 times 300, 300 times 20, 300 times 5. And then you start with this part of the multiplier. And there it is. Answers all those partial products.
So this gives them a good baseline for differential equations then.
Well, I guess so.
Yeah, it should.
Does it?
So at what point, because this is a whole process of visualizing it, when does it get abstracted? Because it's such a long process, and do they get lost in the process itself and don't capture the abstract? I mean, does
But
it
they're
happen?
writing it while they're doing it, that's the abstract.
So here's the abstract. Let's say the U cube. Let's start with the U cube.
Are you saying when do we get to lose this entirely?
No, but it's just that translation from this to.
But they've been doing it all.
See, I get this, but see, this is something which is kind of abstract in the sense, you could do
Yeah.
it regardless of the
That's right.
material.
Yep.
That's how we
But
were
this-
taught, right?
Right, this is what you're taught, but this is the visual part. How does this kind of transition in your mind as this is what this is?
I know, but backwards, we do it from primary up because they're visual and concrete.
Right.
We just did it this way, but don't have this part. The kids have this part, and then it's easier to do that part.
Right.
And then in middle school, when they have to manipulate it, they can see things. I can't see this.
Right.
I don't have this.
So to equate this, right?
Yeah.
And-
You know what
Sorry.
wood feels like, right? So we don't ever have to tell you it's wood and it's hard. You just know wood is hard. That is the same basis that is happening here.
Nice analogy.
No, and I get it, and the thing is, they've been doing this for a long time, so I get it, because, there's a light bulb there for them, I don't see
I feel like at
So how do you
some
think
point
this
when they're
prepares
doing
them for
this and then they're
differential
just
equations?
Yeah, that's.
Well,
Yeah.
so the
Like
difficulty,
Yeah.
right, when people hit pre-calc and calc, right, is it is purely abstract. Really, you're not even going to numbers most of the time,
And
right?
that's how you make it.
And when you go into that medium level math, right, a lot of people are just like, this is so pointless. That's one part of it, right? The other thing is they're like, they cannot understand where this is coming from. What you're providing to them there is, this is where everything's building from.
That's the
Right.
pattern.
It's like the concept
It's
of
the
wood is hard,
process.
this is why you want to build out of wood, it's
Process.
hard, it can hold things, right? When
Mhm.
you look at it from a concrete standpoint, okay, you understood wood is hard, now you understand you could probably put things on it because it's structurally sound, and then you start taking that out and say, okay, well, how much structurally sound could it be, what type of woods, etc. It's just the higher order of it. The same thing would be true on math. Once they understand practically, okay, this is what all this looks like, which probably my math skills have been far better had I done something like this.